It's the cloud. Yep. So now it's recording. Anyone has any question, any specific question? Or else we can start doing the review sheet that he gave. Any question? Okay, so let's go over the review sheet. So let me share my screen. Okay. Can you all see the screen? Yes, great. Okay. So, what do you guys want to do first? Do you want to start here? Okay, let's start here. So the question is, consider the following class and interface declaration. So interface mean it is like a template. Okay, so which means if you implement something from the interface, you need to write all the methods, you need to define all the methods inside the other class. So here, but like here is there's no code in the interface. So we assume that there's nothing in the interface right now, but class B implement class A. So it need to write all the methods in the class B. So this is just a normal like a structure of the interface. But like the question is, which of the following lines of the code will cause an error? Okay. So the first one is class A. So I create an object of A. So which means I create an object from the interface. Do you think can you make an object from the interface? No, you cannot. Okay, you cannot make an interface. You cannot make an object from the interface. So the first answer is wrong. Then another one. So A, so class A object, but new class B. So this is called polymorphism. Okay. So which means that so which means that class A, so object B inherit or accept all the methods and property from the class A, but like it create an object of B. So which means this will not give you an error. Okay, so run curly. So this is the best way to create an object, which is like object B, so which is from the class B, it create an object. So it will not give an error too. This is correct. So only the answer A give you an error because you cannot make an object from the interface. Got it? Any question about the interface?
What's the difference between number 2 and 3?
Number 2 and 3. So the difference between is that so in here, let's see. Let me think of some example. It is not top of my head. Sulaiman, do you know any example about number 2?
Where you declare something from an interface?
Yes, like what is like different between this and this? I
Well,
Go.
number 3 is a straight up constructor. Do you see that? Like 3 is a straight up constructor. So for 3 to work, we see that class B has a constructor. But because well, actually, would it work? Because can we assume that, I mean, because B is implementing A, so that means B is a type of object from A. So if you want to think about it, using line 2 is basically saying we have an, because like we're creating a new object A that's type B. Like that. Let me just write it out so you guys to see. So like see how A is an interface here and B implements A. It's like B, so we have like a little hierarchy. B and you have A, right? It's kind of like asking people, oh, does a square count as a rectangle? A square is a type of rectangle, so it like technically is, but you can't do this. But you can do this because technically when you say you're creating a square, that's also like a type of rectangle. That, if that makes sense. Hopefully that does. Like you could create a new square from a square, but you could also create a new square from a rectangle. Yeah, that's why. Got you guys.
Oh, thank you. Yeah. So like basically like these two are similar. Like the property of these two are very similar, and that you can create an object like this because B is belongs to the A. Okay. Okay. All right. Any question with this? Okay. I will take as no. But like, if you have question, like I'll move this again back. So okay. So next one. What class is the super class of all other class? This is like a theory stuff. It doesn't that you should know. So what is it? It's like the hierarchy stuff, and then it's all like extend. But like, what is the highest one? I think let me just see. So if you see the graph, you you will understand more rather than I explain. Yeah, it is object. So let me see. Java object hierarchy diagram. So let me la, 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 la. Okay, yeah, you can, let's see, which is the best thing that I can show you. Okay. No. Yeah. Yeah. So let's take an example of this. So right here, as you can see, all the object, all the methods is from the class. Let's see. Oh yeah, this is the best thing. So here, so Java language is on top of everything. Okay. However, the object is the second highest, but like this is you can see it's the highest object, highest class. So this class contains like everything. First contain is variable. Now in the variable, it contains the error, the exception, and all things, all the exception, the error. And then objects also contain all the methods that you write. It is inside the object. All the class that you write is inside the object class, which is, I mean, it inherit all the property from the object. That's why object is the like highest hierarchy among the class. It's a superclass of all the class. That is why it is an object. So like let's look at some other example. So class is like it inherits the object. So there's a class is the big thing. Exception is here, right? Exception is here, which means it extend the object. And instance is oh, so this diagram doesn't have instance, but like it inherit the instance also inherit the object. Okay, and then the super is also the class. that inherit the object too. That is why it's object. Okay, let's look at number 3. You're designing an OOP that track passenger for an international airline. What would be the best relationship between the nationality, passenger, and then an accompanied minor class? So let's look at option A, the nationality and the accommodated. Sorry about that. Let's say, okay, I will just say the minor. The nationality and minors are both field of passenger. So, which mean that it's a both field of passenger. I mean, passenger is like a big thing. Here is the passenger. Does it like nationality belongs to the passenger, which is correct? And then like it also like it all things like belongs to the passenger means the passenger, and then nationality is like both field mean like nationality is it's also passenger. Like it's inside the passenger, and then the minors are also inside the passenger, which is not true. Like nationality, the passenger like has the nationality, the national like passenger. When you think of the nationality and passenger, so every passenger belongs to the nationality, right? Yeah, it is C. So let's think about why it is C. Okay, so nationality is a field of passenger. All because like all the passenger belongs to the nationality. Okay. However, not all the like unaccompanied minors belong to the passenger. Okay. And also because like nationality is not a subset of passenger because all the passenger belongs to the nationality. It's a one group. Passenger and the nationality are in the one group. However, the minor is like all the minor is not a passenger. All passenger have nationality, gender, etc. Yes, that is correct. What are the defining SFC? That is correct. And then what are the defining differences of the field and the subclass? A field, okay, let me write it down here. So I would say here is a class or passenger. Okay. And then what does the field mean? Inside the passenger, you have like a string called nationality. Nationality is a field of passenger because every passenger need to have like a nationality, right? And it is not like another subclasses because it doesn't like extends or something like that. It is a property of the passenger. And then subclass, the subclass mean like this. So we have another class called an accompanied minor extends the passenger. So this means that this is a subclass of the passenger. Okay. Do you see the difference between the field and the subclass? Subclass is like a lower class that extend the passenger. Like in the airplane, you are like all other passenger, but it's like there's another rule that also extend the passenger, but like it is another group of like minor. We say it's a class. Okay. If A is a B, A should be a subclass. Yep, no problem. If A is a B, A should be a subclass of B. If A has B, B is a field of A. That is correct. A class has a teacher, so a teacher is a field of the class. That is correct. A student is a person, so a student is a subclass of person. Yep, that is the good example. Love it. Okay. All right. Any question with this problem? Okay, let's move to the next one. The next one, consider the following class declaration. Public class full, and then the bar extend the full. Okay, so it extend all the like properties and like all the fields and all the methods. It extend all things from the field from the full. It has a method called run inside the bar. Okay, and then the following code segment contain an error. Full x equal to new bar. Then I run the x dot run. Give you an error. Let's see why. This is the following chain will fix an error. So, the reason it is wrong is when you create with the full, with the x value here, it like there is no run method inside the full. Do you see that? It only the run method, like it only like only chai class has a method called run. Okay, that is why it gives you an error because it doesn't have like run method in the full. So one way to fix it is like write the like run method here. That's one way, but it doesn't like have the option here. So let's see. So one way is full x equal new full. That is completely wrong because there is no run method inside the full class. So you cannot call it. However, the bar, when you create like a bar method, bar object, you can call the x because the run method is inside the bar. Okay, so this is correct. This is very straightforward. Then you can change the second line to the bar x dot run. Why we can change that? Because we use the polymorphism to define like this, which means these like full and bars are related so that you can define the x to be at x like a bar. Because like by default, x is like from the full class by default. But you want to call the run method from the bar so that you specify the bar class so that this x object will add x like a object from the bar. So that this is also correct. So the answer will be number E. Okay, any question? You mean like option 3? Yes, it is like a downcasting. Yep, changing the full x to like a bar object. So it will only add x. It will not change like completely. It will like when you call like this method, I want this x to add x like a bar so that I can run. Because like you can call the bar because like you use the polymorphism property to initialize to create an object like this. If you create an object like a full and new full, you cannot call like a bar x dot run. That is correct. Yeah. Okay. Any question with this? Or do you guys understand like how the inheritance work in general? It usually work like top to bottom. So all the child has the property from the parent, but not the parent cannot have the property from the child. That is why this fool cannot call its child method. Okay, sounds like there is no question, so I'll move to the next one. So number 5 is which of the following cannot be present in the abstract class? Okay, what is abstract class? Okay, what's the difference between like abstract class and then the normal class? There's only one difference, one main difference. What is that? Abstract class has some abstract method. That is correct. That is correct. Yep. I mean, yes, you can have like that. That is correct too. It is like a interface. Abstract is like between the normal class and then the interface. It's in between. But like there's one obvious thing that different from the class, the normal class. You cannot create an object of that. Yep, that is important. You cannot create an object of abstract class. That is what different from the normal class. Because other than that, you can have all them in the abstract class. You can have an abstract method. No, you can have a field. You can have everything. You can have constructor, you can have concrete method, you can have every method. But you cannot create an object of that abstract class. So basically, abstract class is a class that cannot create an object. That cannot create an object from the another class. All other things the class do, abstract class can also do. So that is why it is the answer is E. Do you get it? It's easy one. But like however in the interface, okay, it's not abstract class. Let's say if it's an interface, interface doesn't have abstract method. Wait, does it has? It has like a abstract method, but I don't think it need to specify it's abstract. And then it does not have constructor in the interface. It can have fee, and it can also have the method. But if you say the classes, the name of the classes in the interface, you need to define in the class that you implement. You will see like in the coding example later on. You will see that. Okay. Any question? Okay. Sounds like good. Okay. So let's go to number 6. So which of the following statements abstract class is true? Okay, let's see. Abstract class can contain private field. It can contain which cannot be directly accessed outside of the class. Yes, you can. You can have a private field or public or protector. You can have all that. Any concrete method in the abstract class will be inherited by its subclasses if not overridden. That is also true. Abstract class also acts like an inheritance, which means the child class can inherit all the classes. It does not need to be overridden, but you can override, but it's not necessary to write it. It's not required. And then variable of the abstract class type can be declared to hold object of the subclasses. The variable of the abstract class type can be declared to hold objects of subclass type. Okay, that is a little bit of a technical thing. So a variable of the abstract class type can be declared to hold objects of subclass type. Okay, so how can I explain? So in the let's say in the abstract class, let's think about that. So in the abstract class, you can definitely declare some variable called like abstract sum variable. Okay. So that variable, let me write it down. So it's like abstract plus, let's say something call something, let's say number. Then in the abstract class, I would do like abstract in them num. So you can have like this, which means you have a variable abstract class type can be declared to hold object of the subclass type. So which means you can declare it in the subclass, you can declare a variable in the subclass so that another class called, let's say, event is extend number can also use this variable. You don't need to like declare again. It can use this abstract variable to use in another class. That is what also like abstract class, because like it is normally just a normal class, just a abstract. So that like you can define it here, like name is equal to 3 or something. You can do like that in the abstract class. Okay, so that is why E is also true. Okay, any question about these? Sounds good. Okay, so yeah, before moving to the coding question, does anyone have any question about like normal topics? Any question, any general question about this? Yes, so this will also be posted on the Brightspace. I'm not sure on the Brightspace because professor need to be uploaded, but I am sure. So if you go to like a learning comment website, and then learning comment website, and then you go to the resources, and then in the resources you go down here, you go to tutorial. So here, so after the recording is done, like other recording processing is done, the YouTube video will be uploaded here. Okay. So yeah, so I think this will be uploaded like at most tomorrow. Yep, I will make sure it upload tomorrow too. Yeah, yeah, probably by the end of the tomorrow. Okay, we'll see it here in the learning comment. Let me give you the link. Also, like, we will also inform the professor, so professor will also maybe upload it to the price space. That is, I think he will also upload it too. Okay. Can you briefly compare abstract and interface? Okay. Yep. Let's see. Let's see. Let me think about some examples that I can use. Um, give me 1 second. Let me find an example. Hmm. Um, okay, let's see. Here, it's not coded. All right. Okay. Let's me do like this. Where should I write? Let's write here. So let's talk about interface first. Okay. So because like we will talk about the abstract like a bit more. So abstract is like mostly a normal class, but it cannot be created an object. It's basically like that. But like let's look at the interface. Let's review it, the interface. Oh, let's see. So you declare like a public interface subnet called X. In the interface, we can have some of the method. So it's a y is a method. Okay, it has an integer called z. It's a parameter called z. And another method, public void q, is here. Right? And then, so this is the interface. Okay. And then, okay, I want to implement that interface. So how should I write is public plus a implement the x. So as soon as you implement, you need to implement these two methods. Okay. So which means like it can have another method too. Let's say this is like a public, like say this is void call other. This is like a other method. So it has something in it. Okay. However, we need to also define all the classes or all the methods that is inside the interface, which is the first thing is public, then y, and z. Let's say return z plus 1, something like that. Okay. And then another method called public void q. Then I say the center outer brain ln call like uh this is from q. Okay, so I define like both of the class, both the method from the interface. So if I don't include one method like this, if I comment out one method, it will give you an error. Okay, so which means that the interface is like you must define all the method from the interface. And also, the same as the abstract class, you cannot create an object. So which means that in the main method, okay, so this is the main method. In the main method, you cannot create an object, which means you cannot do like x1 equal new x. So this is wrong. It will give you an error. So this is basically the interface. So let me give you an abstract example. Okay, so let me write, okay, here. So abstract is, so it's like a normal class, which is like, I think we can, again, let me copy it here. Okay, so let's see. Okay, here. So this is like a abstract class, which means that it can have the normal method, also normal properties, normal methods, all this method. Okay, here. So this is like when you want to use it, you need to like, you cannot use that class directly, which means you need to create like another class, and then you extend the class. That's how you use the abstract class. Because like you cannot directly use it. So public as, let's see, I don't know, let's see, word of art. It's like painting, picture, extend, oops, extend that. Okay, so in the picture, like not in the like implement, you don't need to implement this method. I mean, sorry, like you don't need to like implement again like these. Okay, like you don't need to, but like you need to define this. It's an abstract class, sorry, abstract method. Okay, so we're gonna define this price method here in the extend method to be able to use it. Okay, so this will be gonna define public double get price, and then you define something here. However, you can use all of the method like without defining it again. Right? So you can say, so the idea of that is like in the interface, it's like a template. So every class that implement that interface need to have all those methods. So it's like a rules to make like class. So abstract class is that it's like another class, but like I don't want okay, like it's like an encapsulation. Okay, encapsulation is mean I don't want like this class. I don't want like to know how this class is built. Like abstraction, which means you don't know how it works. Okay. However, so how it work mean like you don't change the code inside this abstract class, but if you want to use it, you can use it calling the extend method. And then if it's an abstract, you need to define that how it is, because it's abstract means like you can, otherwise like if you don't like define it in the inside this like picture class, you cannot use it. That's why you must define that I forget what of that. Okay. Good. Sounds good with the abstract interface. Okay, no problem. All right. Okay, now it is coding. Okay. Okay. Suleiman, do you want to do these two? Since we only have two problem.
Sure, sounds good.
Okay, so I will hang over to Sulaiman. Okay, but I will be in the chat. You can ask me anything. Oh, yeah. Okay, so let's hand over the Sulaiman.
Thank you, Mike. Thank you, Mike. Just pull it up real quick. All right, let me share my screen. Share. Because does everyone see my screen? Yes. Okay. Thank you. Thank you. Thank you. All right. Hopefully everyone's doing well. I know you just had your first midterm. Now another one's coming up. A bit weird. Seriously, this semester's flying. So, anyways, so we're gonna do the coding question. Does anyone have any questions about any of these questions from before we start the coding? If anything, we'll go over them at the end again, but everyone's good. Okay, so you're an artist who makes paintings. You sell the original pieces as well as prints of your work. You have the following abstract class. Yes, abstract class to represent your works of art. So we got this. Once again, like Mike said, in abstract class, you have a lot of these. You could choose which ones you want to use. It's kind of like a template of sorts, but it's like more flexible. So we got height, width, height. We got this method, work of art. We got get width, get height, and get price. Okay, so this question involves the implementation of a class called painting, a subclass of work of art. Each painting has a set price. Each painting begins unsold. The following is an example code execution sequence. Okay, so I'm gonna, all right, sure. I'm gonna write the code here. Let's write it here. Okay, so painting is a subclass of work of art. So we have to write, let's do this. This is public class. If I do make a mistake, everyone here, please feel free to correct me. Extends. It extends, right? I'm not blinking. Extends. What is it? Work of art. Of art. Okay. Okay, so let's do this. And what do we see? We see that painting has a set price. So this, the set price, let me just do blue. Each painting has a set price, and each painting begins unsold. So what does this mean? This means that this subclass of painting has its own variables that are specific to it. So if we let's do that. Oh, let me type. Okay. So let's do it. So we're gonna have a double. Let's do private double price. And we're gonna have a variable to show whether or not the painting is sold. So let's do Boolean. So we'll do private Boolean is sold. And since it says each painting begins unsold, just say false. Okay. Is everyone good so far on the variables?
Yeah.
Alrighty. So now we have to include two methods. So get width, get height, get price is sold, sell is sold. So let me just point something out before we start. Because this class extends work of art, we see that we have two methods here. Well, I'll do the constructor in a bit, but we have two methods here that we use, get height and get width and get height. These are directly from here, right? These are directly from here. So for those, we can do public. Do we need to actually I don't even think we need to create those because we already have them. Okay, we're good. So those we need to ignore. We need to create the get price method. Get price method. get public double get price. And we need to have is sold, right? Public double is sold. And we need to have dot sell. So it's going to be a public void dot sell. Okay. So let's implement these real quick. So get price. If you want, you could always use the examples the professor gives as templates. So the get price, keep it the same as how they write it. So this just returns the price. So return price. I'll do the constructor in a bit. Is sold. This just returns is sold. Yeah, sure. Because remember, is sold is a Boolean already. So we just got to return. So if the object is sold, you return false. I mean, return true. If it's not sold, you return false. And for sell, well, then this just updates things. So it's return, not return. Sorry, this is void, so it doesn't return anything. Is sold equals true. But both be Boolean, not why does it need to be is sold? Oh yeah, you're right. Sorry. Thank you for pointing that out. Like I said, guys, I'm gonna make a ton of mistakes. So please feel free to point them out. What before for sell, we need to check one thing first. And that is, well, what if our painting is already sold? So if the Boolean is sold for painting is false, then we could sell it. Right? So I have this beautiful painting right here, a work of art. This is gonna be me right there. The dude. If this is sold already, then this is gonna be true. It's gonna be true. So that means I can't sell it anymore. Right? Which is why for here we have to include an if statement. If is sold. I'm going to put a not here, right? And I'll show you why in a minute. If not is sold, then you set it equal to true. This is basically saying if is sold is false, then not is sold will be true, which means then we could sell it, right? If is sold is say true, then not of is sold is going to be false. So then we won't sell it. Is everyone good with this if statement? Anyone have any questions about it? Does everyone understand why we have this statement in the first place? We can only sell a painting if it's not sold in the first place. If it's sold, we can't sell it again. Everyone good with that? I will take the silence as a yes. So everyone's good. So these are the methods. Constructor. Can't forget to write that as well. So I'll do that now. Public painting. We're gonna have 3 parameters, right? 3 parameters. So let's try to match this. This is gonna be 17.5 is from get width. So that means this is the width, right? Get height prints 12.5. So this is going to be the height. And get price prints 49.99. So it's going to be the price. So let's have 3 parameters. Double super with, yeah, we can do that. We can do that. Let me just write the first way first, and then I'll write the second way. But yes, to the person that says in the chat, Phoenix, you are most definitely correct. So let's just show it ways. That's like the more correct way. That's like the better way programming wise. But instead of doing so like W width, right? Double length, double price, right? And we do all of this So we set width equals W, length equals L, price equals P, right? This would be like the more arduous way of doing it. But remember, this painting extends the work of art, please. Work of art, right? So we could technically use the method here. We already have a method that includes the double in the height, right? So we could just use that. So we could do, like Phoenix said, we could do super. We would have to have also, oh, just to be sure, for a little edit, we would have to still include these as a parameter, Phoenix, because see how when you in the code you wrote, you said double price, but in the painting, in the code given, there's 3 parameters. It needs to match. There has to be 3 parameters for painting as well. See, 1, 2, 3. This is yes. So you still use super, no problem with that. But you would have to include the two. So we would do super W length and price equals P. If you want, this is if you want to avoid using this. If you end up like if you write it like it's a bit, yeah, it works okay. So if you write, erase this. So never mind, it's gonna erase everything. That's not gonna be good. If you're double width, double length, double price, then you have to do super width, length, and then you have to use a this dot price so that the computer avoids confusing one for one, this price and this price. Super in the painting constructor. In this one? Well, yeah, here because we have to, because remember, painting is a type of work of art. So in order to, let me just go back to P W length price. We would have to include super in the painting constructor because remember, painting extends a work of art. So every painting is a work of art. So when we use the constructor, we would call super, and now we can call the constructor for this. We would call the work of art constructor, right? Without this super here, we would either have to manually do it like I did before, or we like would have using super or manually inputting it would be the only two options. Because otherwise, how would it store the width and the height and then the length? Is this? I'm sorry, it says height. H. Okay. W. That's height. Guys, you gotta correct me. You gotta correct me. Making mistakes. Does that make sense, though, Josh? If you don't include the super, you could just write it out like you could do you could write it out like width equals W. Yes, exactly. That's the whole idea. Like technically you could just write it as this, width equals W, height equals H, like this, and you could exclude the super, right? And this is perfectly fine as well. This is a perfectly correct code. But the idea is because we extend a work of art and work of art already has a constructor of its own, why not make use of it? No? No, it's gone. So that's why we do super width and height. This is kind of like better coding, right? Because if you think about it, this is the same thing as this. So we're technically repeating code, and that's the whole idea of like having this is to avoid repeating code, which is why we used to do super. Does that make sense? Everyone good with that? Everyone okay? Good, good, good. All right. Everyone's good. All right, let's move on to the okay, the print class. Not shown is a subclass of work of art. A print costs $10 if it's smaller dimension is less than or equal to 8, and its larger dimension is less than or equal to 10. However, otherwise it costs 30. Write the get price method for the print class. Okay, so for the print class, we don't need to write the entire print class. You just need to write the get price method. So this would be public. I'm gonna write double just in case. You could write int. Like if you write public double get price. Print class. Yeah. Oops. If you write it with int, I don't think it would be incorrect because it's 10 and 30, but I would put double. I'm putting double. Why not? Prices are usually doubles. So get price already implemented in as an abstract method. Where? Write the get price method for the print class. Oh, okay. So then, yeah, it's double then. Okay, we're good. Well, yeah, all right. My bad. I got confused, everyone. Here it's written as a double already. So we just leave it as double. Ignore my stupidity. But yeah, it's double. Thank you for pointing that out. So, get price. So it returns, let's just put return 30 here at the end. Why? Because you guys will see, because it's basically saying otherwise it costs 30. So if nothing else happens, it will return 10. So let's keep track. So once again, you could solve this in multiple ways. I'm just thinking of the way that first comes to my mind. If you guys feel that there's a simple way of doing this, feel free to do it that way. So let's do this. So a print costs $10 if its smaller dimension is less than or equal to 8. So let x, let's have double, let's say have smaller is equal to math.min of width and height, right? And we're gonna have another one, double. You can do this without these. Bigger equals math.max with. Did he teach you guys the math.min method and that math.max method? Yes. Okay. So yeah, here you go. This is, I like math.min and math.max. They're nice. Okay. So basically saying if blank will return. Oops. So what are the conditions? If its smaller dimension is less than or equal to 8, so if smaller is less than or equal to 8, and its larger dimension, let's say bigger, is less than or equal to 10, then we return 10. Return 10. Otherwise, we return 30. And this pretty much is. This isn't too bad of a method. Okay, is everyone good with this? Does anyone have any questions? Any questions at all? Also, I think because it's 5. For anyone who might have to leave early, Mike, if you could please fill in the feedback form. Mike will post it in a bit. Just so that for anyone who needs to leave early before we forget. Feedback is very important, as you guys know from our last lesson. But does anyone have any questions about this in particular? Did everyone good with this? Like I said, if you guys can always do this in a different way, you don't need to use the math.min method. You can always use if statements and etc. But it's like this is cleaner in my opinion. Is everyone good? Everyone okay with this? Any questions? Okay. So for the following free response section, consider the set interface. So this is an interface, meaning we have to include both methods. A set cannot contain duplicate values. So we got public interface set, Boolean contains double element, double size. Part A, you will write the entire array set class, which implements the set interface. The array set class must conform to the following example code execution sequence. Okay. Double array 3, 2, 3, 4, 3. Array set equals new array set array system yada yada yada. Okay. I'm ready here. Okay, let's write it. Let's write it. Okay. So we got public class array set implements set. Because it implements set, what two methods must we have? We must have double size. Boolean contains. Okay. Boolean contains double elements and double size. Double size. Okay. So we also need to have a constructor that takes in an array. So this would be array public. Sorry, I forgot the publics here. Public Boolean. So it's going to be public array set. We have the array of doubles, so double array. All right, so this one's a bit weird because you guys have not learned hash sets, which is unfortunate because that would be very useful in the situation. Okay. All right. Okay. Anyways. Oh, we can use array list. We can use did Steinberg teach you guys array list? Whoa, that makes everything easier. Okay. So we got array list. Let's do a list of doubles. So I learned to doubles, let's say set equals new array list. The reason why I'm saying that makes it so much easier because now you just do this. So let's first do contains. I'll show you guys why. Basically saying contains is this. If set dot contains element, then what do we want to return? We want to return true. Yeah, return true. Else, oops, sorry, there has to be return. Return true. Else return false. Okay. We'll also have a actually, the reason why I'm saying this is good is because now you just have to return set double set dot size. Okay. Does anyone have any questions about these two methods? Like I said, because you guys are able to use array list, that makes it so much easier. I spent the last like 30 minutes thinking how I'm going to do this with array, so that was not too much of a big deal, I see. Is everyone good with these two methods? Right, we can just use the fact that array list already has these methods available for us. Dot contains, or actually we just return set dot contains elements. Okay, that's good. That's even better. Okay, remember we're using an array list, and array list already has these methods, so we just use them. Okay. So now we have to create the constructor. So this means we have to go loop through. So we would go do a for loop. So you guys have learned how to use a for each loop. So I'll be using a for each loop. You can use a for int I equals 1, 0, yada yada yada. But actually, let's do it that way. Int I is equal to 0. I is less than array dot length. I plus plus. If, all right, so let's do this. If, what do we have to check? We can only add elements. We only add an element to the set if it's not already in there. So how do we do that? We could do if set does not contain, okay. Yeah, so if set dot contains array I, right? That means we don't want to add it. So let's do a not here. So if set does not contain the element, then we could just use the add. All right, then we want to add it. Set dot add. It's an add, right? Array list. I'm not. It's been a while. One sec. It's add. It's add. Yeah, they have a dot size. See, they have a dot size here. They have a add. It's good. And contain. They have a dot contains. So that's good. We're good. We're good. I want to use search anywhere. Set dot add array I. Okay, that's pretty much it. Is everyone good with these methods? Is anyone good with this? Like I said, for these, like for the size, you could always like keep extra variables, but because we're already using an array list here, right? We don't need to like repeat. The array list already has these methods. So we can just, the reason why I'm saying double here is because the size returns an integer. Yes, size returns an integer, so we gotta typecast that into a double since he wants double size. Okay, so that's the only slight change we have. Everyone good? Everyone good? And like for this, if anything, we just do this because we already have a contains method. So, right? Is everyone good? I'm taking at least 2 responses before I move on to the next part. Waiting. Yes, that's 1. I need 1 more people. I need audience participation. It's been too quiet. That's number 2. Okay, we're good. I like how when I say that, everyone starts responding. Yeah. Anyways, for part B, considering the following methods, all in the same class, combine sets. Okay. Sets. Hold on. Is set supposed to be an, oh, never mind, I'm sorry. Is set supposed to be an array? Set's an array. Okay, it's fine. Sets, private, combine sets, set combine into finite sets. Combine sets, case 1 parameter is infinite. Combine into infinite sets. The combine sets method returns the output of one of the other two methods, depending on whether the parameter contains an infinite set. the size of an infinite set is equal to the positive infinity constant in the double class. Complete the combined sets method below. Okay. Combined sets method returns an okay, yada yada yada. So let's do this. All right. So we got this method. What is that? Let's do public static set combine sets. We got sets. Okay. So this is going to return as a set. So we're going to create a new set object. Well, actually, we could use the methods here, right? So we have, so the idea is we have to go through, let's, chat. Yep. Please feel free, please fill out the feedback form. We won't get paid otherwise. I'm joking, we still get paid, but anyways. Size of a set. So here we only need to fill out this, right? He's assuming, okay, we only need to fill out this method. He's technically like giving us these, right? He's not giving us what's inside. So we don't need to worry about what's inside. We just need to know that the size of the set is equal to positive infinity, a constant double class. So we only need to use one of these two, right? So this is not like we're gonna write out the code by ourselves. We're gonna use one of these two methods, right? So what's the idea here? What I'm thinking, guys, so here we use a for each loop. So for set in sets, right? We want to check this. If one of the sets, right? If one of the sets dot size, so if say set dot size is equal to positive infinity. No, he gives us this here, so we can use it. Just highlight it right here. He gives us positive infinity. So if one of the sets dot size is equal to positive underscore infinity, right? Then what does that mean? That means we have to use this method, this one, private static set combined into infinite set right here. At least one of the set in the parameter right here. So let me just line that. At least one set in the parameter is infinite. Okay. So we basically loop through the sets. If we find one that's infinite, so this is one that's infinite, then what do? We just use the method. We just return this. We return combine into infinite sets. Okay. I see a question. Double dot positive infinity. Oh yeah, okay. Double dot. Yeah. All right. Thank you, Mike. Because this is a positive infinity in the double class, we would have to use double dot positive infinity. Right? Otherwise, we loop through all of this, we find no sets that are infinite, and we do this. We use the other method. All sets in the parameters are infinite. We use it. So combine into finite set of sets. Okay? The helpful thing is that he gives us these methods and tells us like you don't need to like actually code out the combination into a set. You just need to use those methods. It's all about this portion, like looping through each one and then finding whether one is infinite or not, and then using the corresponding method. Okay? Is everyone good with that? Does anyone have any questions about this? Any questions at all? Nothing. If something doesn't make sense, please point it out. Or if I made a mistake anywhere, please point it out. I don't want to give you guys false information. Steinberg is going to come from come to my head. He's out for me. He's out for me and Mike. Mike, we're gonna be screwed if we screw up these students. Does anyone have any questions? All good, all good. I'm gonna take the silence as everything is good. Okay then. Okay then. So we're actually pretty early. So I'm gonna go to the beginning. Does anyone have anything from here that they want to go over? Anyone want anything from here? From any of the topics that he said? Speak now or forever hold your silence. And once again, I'm gonna be very annoying about this, but please fill out the feedback form. We still have a couple of more of these to go, so if you give your feedback, it will be very helpful in letting us know how we could improve or what we could do differently. So let me put all of them on screen. All right. There you go. Does anyone have anything they want to go over? Shouldn't be bad. Cyber's exams seem good. They seem fair. Anything at all? For anyone who might have came in late? QC learning commons. Let's just show you guys where it's gonna be. This is why I hate using Microsoft Edge. Resources, computer science. Can you briefly explain the short circuit again? Sure. What's that one? That's what the if statements, right? Sure. Short circuiting. That's what the if statements, right, Mike? I'm not hallucinating. Where we have the if statements, we have like something like this. If we'll have two if statements here. Let's do system.out.print statement 1. Now if system.out.print statement 2. Okay. Got you. Okay, so the whole idea of short circuiting is that when it comes to, it only applies to these two operators. We have this one, the OR. This is the OR operator. We have, I'm going to try my best. That one. There you go. This is the AND operator. All right, so the whole idea between ORs and ANDs is so we have two statements. So we have A or B. Then this is only true when one of these two are true. They both could be true, but this is only true when one of these two are true, right? And if we have this, so A and B, this statement is only true if both of them are true, right? So these both need to be true. If one of these two are true, the OR is true. But if both are true, then only then the AND is true. Right, so let me give you an example right here. If we say if 1 equals 2, or I'm going to do that. If 1 equals 1, or 2 equals 3, then print out statement 1. Okay. So let's see. Does 1 equal 1? Yes. So what is it? So the whole idea of short circuiting is that we don't even need to check this second statement, right? This second statement can be true or false, doesn't matter. But because this is OR, and we already have a statement that's true, then the entire statement is true. So that's why we print out. That's the whole idea of short circuiting. It saves us like time and like running. Like, even though it might seem like really fast, so why not just check another statement? But the whole idea of short circuiting is that it saves a lot of time, like for the computer itself, like on an operating system level, right? Whereas if we wrote this, like, so if 2 equals 3, or let's say 1 equals 1, right? We look, does 2 equal 3? No, right? And no, I'm sorry, this is supposed to be and. I'm sorry, guys. And 1 equals 1. Does 2 equal 3? No, this is false. Let me just write it out. This is true. Sorry, right off that, we don't even need to know what this is. We just know the entire statement is true. And here we know this is false. And because this is an and, we know that the entire statement has to be false. Okay? So right off the bat, we don't need to print out. We don't print this out. Does that make sense? Yes, and Aisha, does that make sense? That's the whole idea of short circuiting. It just saves some time for the computer. No problemo. Alrighty. Does anyone have any other questions about any of these? Anything else? Well, let me finish showing. So, like Mike already showed it. So you're gonna see here. This is our last video. Our next video is gonna come up here. The final, I believe, is 12:15. So that's that. All right. And yeah, there you go. This is where you'll find the recordings. And if anything, you'll most likely get an email from your professor. If not, like some sort of announcement from your professor about this recording and the review session. And you'll be able to find it from there. Okay. Does anyone have any other questions about any of these? Can you shortly explain interfaces? Sure. Let's go to one interface real quick. Also, for everyone who needs to leave, please fill out the form. Please fill out the, what is it? Mike, can you send again? Feedback form. There you go. All right. Thank you, Mike. So let's go to interface question right here. All right. So don't get an interface confused with an abstract class. So the whole idea of an interface is like when you have, let me explain it like this. So here we have an interface called set, right? But we're not actually like writing out the set. This is kind of like giving us a template for how we organize a set, right? This is basically saying, this is kind of like a template in sorts. This is a template. Okay. It's basically saying whenever we have some sort of set later on, like here we create an array set, any set that uses this template needs to include these two methods, right? That's basically what an interface said. That's basically blah, can't speak. That is basically what an interface is. It's a template that allows us to create objects that are based off of this, right? It's kind of like if you have an interface of, let's say, shape, right? We have an interface of shape, right? This is shape. This is, and we have different types of shapes. Like this may be a different example. Actually, yeah, you can use it like this. We have a rectangle, we got a square, we got a circle. But all of those have like certain aspects. They have area, they have a method for area, they have a method for perimeter, right? You can't have a shape without those methods. So whenever we have any shape, regardless of whatever it is, they all have to have some shared methods, right? That you have to have. That's the whole idea of an interface. You have to have these methods. Whereas, like, say, an abstract class, yes, exactly. Here, like, these are things you can have. Like for a work of art, you can have the get width, get height, price, right? Because some work of arts do have, like a painting does have width and height. The other works of art don't. Like, you could think of examples on your own, but some don't have widths or some don't have heights, right? Whereas an abstract, right? If I created this an app, if I created a work of art as an interface, this means that every single subclass of work of art needs to have these methods. Okay, does that make sense? So you're saying you understood? Yep. For everyone else here, hopefully that explains the difference between an interface and a abstract, but most likely the whole idea of interface. This is basically a template for any like subclasses to use, right? No problem. Does anyone have any other questions? Any questions at all? Press Mike to send the feedback form one more time, because if no one has any other questions, once again, you will most likely find a recording. If your professor doesn't send anything, you'll find it here. So feel free to go to the Learning Commons website under resources, computer science resources. You'll find it right here. And yeah, I think if anyone had any other questions, no one has any other question. I think we're good. We're good. Hopefully you'll all be perfectly fine and prepared for your exam. It's gonna be a walk in the park, trust me. Right, so yeah, if no one has any other questions, that's pretty much it. We're gonna end a bit early. Okay. No problem, no problem. And once again, thank you, Mike, for holding the first part of the review session. And yeah, have a great rest of the week, guys. You all are gonna do well on the exam. Trust.